Hi, today is the second session in math. Today we will learn on powers and quadratic equations. We will learn ways to solve quadratic equations, methods to solve quadratic equations, also the basics of powers or exponentials, and how to do basic processes using powers and quadratic equations. As last time I indicated to you, this is my email address in case you have any question, but there will be other means of sending your questions, also some interactive sessions. Okay, so these are the rules as usual for powers or exponentials. Um, this is the format, so a to the power of n. This is how you read it. You read a to the power of n. This is the base, so the base of this term, so something like 3 to the power of 2. That means 3 by 3. So 3 is multiplied twice. Or I could say 3 to the power of 4. That means 2 by 2 by 2 by 2. 2 multiplied 4 times. So this is the base. The base is 2, and this is the power or the exponent. So you could possibly use one of those terms: index, power, or exponent. They all mean the same thing. Now, if we use those numbers or the exponentials, so there are rules which we need to use when do the processes, something like multiplication. So when you have a multiplication, you first thing you need to check they have the same base. So the base is the same. Then if they are multiplied together, then very simple, you just add the indices together. So just give you an example here. 3 to the power of 2 multiplied by 3, the same base, to the power of 3. And the answer will be 3 to the power of 5. You just you add them together. If we have division, it's going to be the opposite. When you divide, you're going to subtract the indices. So example here, 3 to the power of 3 of 2 multiplied by 3 to the power of 3. The base is the same, 2 minus 3, that means 3 to the power of minus 1. Now we just down there, the fifth rule, we learn what that means. But for now, this is what you need to learn, or you need to remember when we multiply, sorry, this is division. So when we divide two values or in the form of exponentials, we need to subtract the indices. Okay, raising to the power, so that is when, for example, 3 to the power of 2, and the whole thing is to the power of 3. So this is, I assume, is fairly obvious. Then you just multiply them. So it's not 2 plus 3, it's a multiplication. That means 3, 2 by 3, 6. So you multiply them. And then, of course, that means 3 multiplied 6 times. There is a very useful rule we often come across is anything, any number raised to the power of 0 always equals 1. So 3 to the power of 0, that means is 1, and so on. Every number, every variable as well, raised to the power of 0, that means the answer is 1. Now let's look at the negative index. So that's the one we've seen here. Any number like the one we've seen here, 3 to the power minus 1, you could express this as 1 over 3. So is the reciprocal value. So in this case, because it's 1, so that is just stated in this format. So 3 to the power of minus 1 is actually a third. 2 to the power of minus 1, this is half. And so on. Of course, you could say 2 to the power minus 2, that means 1 over to the power of 2, and of course is 1 over 4. The last rule is the fractional index. So fraction is, just to remind you, x over y. So if we have a to the power of 1 over n, so let's say 4 to the power of half. When you see something like that, whenever you see a fraction, especially in this format, that means is a root of that number. So you need to put it into this format. So it's 4, and this is square root. That means the square root for 4, which equals to 2, because 2 by 2 gives you 4. The square root for 4 is 2. Give you another example. 9 to the power of half. That means square root for 9 equals 3. Or it could be 27 to the power of 3, of a third. That means cubic root for 27, and that means 3. 3 by 3 by 3. 3 times, multiply 3 times, the answer is 27. Now this is linked to this rule because it's actually very similar. Let's say you have 4 to the power of 3 by 2. So that means square root, because you got this half, this is 2 here, the whole thing. So you put 4 here, the same thing, and you put 3. And the answer in this case is going to be 2, because square root for 4 is 2, and multiplied by 3, multiplied 3 times. So that will give you the answer of 8. Okay, so these are the rules for indices. Now we're going to look for more examples, or more, because we're going to link it to the quadratic equations. So we understand now the rules of powers and exponentials. Now we're going to use those to some extent in a quadratic equations. Quadratic equation, you're going to have this form. The difference from when you have x, it doesn't have this sort of power, and because you get more variables. So when you have a curve, you will have more variables. You need more slightly more sophisticated way to solve the curve. So that's often the case with science, because you may need a quadratic equation to express a process, maybe like a relationship between a chemical reaction or a physical process. You need possibly a quadratic equation. And then this is the form. You get x squared, you get x, then you notice you get those a, b, c. And let's agree these are real numbers. A, B, C are real numbers. And this is the format for quadratic equations. We have here